All right, this is the pear deck from Thursday or Friday of September, either the 10th of September or the 11th of September. During class, we did lesson 131. So if you were missing lesson 131, this is the video you would watch to make that up so that you don't have to try to search through all the meets and find the right one. And I just thought that this might be an easier way to do it. So, and it will go faster. It'll be a shorter video than watching the hour of class. Okay, so I'm just going to go fairly quickly and try to just do the highlights and get you all the information you need to complete the pear deck. So you should be working on the pear deck while watching this, and that way you have everything you need. Okay, so let's see what's going on. Okay, in previous lessons, we identified attributes of polygons and categorized polygons that shared various attributes, so it's having the same number of sides or having one or more right angles, all that good stuff. In the next few lessons, we're going to be examining relationships within a single figure. So this one, we're just kind of getting into some names of angle pairs is really what we're talking about today. And so I'm just going to try to get this basically out of the way, but not in that way. I think that will work. Okay. So we'll see if my face is in the wrong place. We'll move it again. It's okay. So single figure or a diagram. Let's see what we got. So one of the things that's really important to understand about what we're dealing with is some rules, and then my face is in the way. See? Just the joy of the face. Back. Oh, my face. See, so exciting. Today we're going to identify relationships between pairs of angles in a diagram, and then we're going to make and justify a conjecture. After we prove our conjecture, we're going to have a theorem. So we'll talk about what conjecture means a little later, and theorem too. A theorem is just a mathematical statement that's been proven. All right, in this course, you can assume that any line that looks, or segment that looks like a straight line is a straight line. It's straight. They're not curving. You will make the assumption that they are straight. We can rely on any markings in a diagram. So what we're talking about with markings in a diagram is, let's say I had a diagram that looks like this, and I've marked, and then I have another angle way over here, and I've marked that they're congruent. Maybe I mark it like this, that they're congruent. It doesn't, you can count on that. You can count that when I make a mark like, I don't know, a triangle, and I mark all three sides as congruent, even if I didn't draw it right, that's kind of the whole point, is that, hey, those are supposed to be the same. These are all supposed to be lines. That's kind of idea with that particular statement. We can assume that all figures lie in the same plane, that is on the same flat surface. So that, in other words, if it's on the same piece of paper, it's all on the table, not some on the table, some on the floor. It's a very important thing that this comes up with really weird relationships. Everything is on the same surface. Very important. And this is the really weird one. You should assume that any diagram is not drawn to scale. And that's really weird. Like, okay, CPM is crazy about this, not drawing things to scale. It makes me crazy. I dislike that they don't draw things to scale. But that is a CPM, kind of a CPM way. They don't draw everything to scale. And so we just deal with it because that's all we got. Okay, so let's see what we got here. Moving forward. All right. So the two angles whose measures have a sum of 90 degrees are called complementary angles. If the sum of the measures of two angles is 180, they are called supplementary angles. We talked about both of these in the video about how to take notes, and I made a stupid analogy to help you remember the difference between supplementary and complementary. Basically, Superman, Common Man, if that rings any bells, if you watched that video and took those notes. These are definitions. And so it's just a matter of, hey, look, this angle 30 and that angle 60. Oh, they're complementary. They add up to 90. This angle over here, 45, and this one, 135. Those two are supplementary. They add up to 180. So that's the definition. It's hard to remember which is which. Complementary is right. It's right to complement someone. Supplementary, it's hard to remember. So it's hard. A linear pair is a pair of adjacent supplementary angles. Linear pairs look like this. Come on, pen. Because adjacent means they have to share one line. And so linear pairs are two angles that are next to each other that make a line. Okay, these two angles, let's have this angle over here and this angle right here, these two angles, those are not supplementary. They don't necessarily make a line. They're just they share vertex, but that's not to make them adjacent. There's a lot of that kind of stuff. So just something to keep in mind, that they have to be next to each other and make a line. Okay. When two lines intersect, like so, and make an X. The angles that lie on opposite sides of the intersection point are called vertical angles. So these two are called vertical angles, and these two are also called vertical angles. Okay, so that's that. Okay. So now what you're going to do is you're going to drag shapes onto the different pictures. So you have these 3 pictures in this. And I'm going to go ahead and scroll this up. Actually, I'm going to just move it over here because I need to be able to change colors. So I have a red circle, a blue hexagon, a yellow triangle, and a green star. And so that's really important. Let's start with green star. The green star is the vertical angles. That's this one. See, that was just like that X I just drew. I was talking about this angle and that angle. The supplementary angles, the blue hexagon. There's actually several different places where I can put a blue hexagon. Supplementary angles, meaning adding up to 180. These two do. I can also put it right here for these 2 angles. Okay, those also are supplementary. Linear pairs, the yellow triangle. Again, this is the one designed to be the yellow triangle, but these 2 angles over here are also so I can put it in more than one place. Those are the only 2 that can go in more than one place. Complementary is my red circle, and that's this one because it makes a right angle. It's the only place the red circle can go, only place the green star can go. These 2 can be in either. So drag away. All right, moving on. Okay, since ABC is in the diagram below, let's see, can I get? I like to have my face because I think it's important to see me, but wow. All right, that's not so bad. Okay, since ABD is a right angle in the diagram below, and ABC and ABD are CBD are complementary. So let's just slow for a second. ABC, ABD, ABD is that right angle. ABC, ABC, and CBD, CBD. That's how you read that. You start with whatever letter that started with. You go to the letter in the middle, and then you finish off with the letter at the end. Okay? That's how you name a triangle. Okay. So CBD, the one that I made blue, is 76. What is the measure of ABC? Well, we can find this by subtracting 90 minus 76, which is 14. So my green angle is 14 degrees. All done. That's it. No big deal. This one's got to be 14 so that they can make 90. In the diagram below, LMN is a straight angle. Straight angle, in which both angles form a linear pair because it's a straight angle. If LMP is 62 degrees, what is PMN? PMN, that's what we're looking for. Well, unlike the last one, this is very similar, but these 2 form a linear pair, which means they're supplementary, and supplementary means 180. So we're going to take 180 and we're going to subtract from that 62, the angle we know, to find our green angle, which is 118. Yes, 118. Okay, And that's it. That's all there is to it. All right, moving on. In the diagram, AED, this one, and CEB are vertical angles. Name another pair, which means we need two angles. Angle AEC and AEC, and angle DEB is one correct way to name the angles. Okay, again, they're straight across. Oh my goodness, there's too many scribbles on that picture to make it even worth it talking about. Straight across from each other. Those are vertical angles. Those are the two I named. The other two were the top two. So there are actually two pairs of vertical angles anytime I draw an X. Okay, moving on. Using the diagram below, determine the measures of three different angles if X is 23. Okay, so X is 23. And so X and this angle add up to 180. So that's AEC. Measure of angle AEC plus X equals 180. So 180 minus 23, which is 7, 1, 47. Or is that too small? It's too small. 57. $157. Yep, 157. Use a calculator if you need to. And so, because they make a linear pair. And then this angle right here, which is the next one it asked for, CEB, that's that one. That angle and this red one I just found, those are a linear pair. So CEB and the one I just found, 157, equal 180. And so if I subtract, I should get 23 degrees for this one. And then this angle here and that angle I just finished make a linear pair, and so that's going to be 157. Okay. On this one, please draw on the mark on the angles because it's writing on the letters is very, very irritating. Okay. Questions? All right. So that's the idea. Okay, now this is where it gets a little bit more, now we're going to actually do a proof. Which pair of angles were congruent and what relationship do the other angle pairs have? So they've labeled B and C. So B and C are congruent. And A and B are supplementary. Or linear pairs, whichever you want to use, which means they add up to 180. Also, A and C are also linear pairs. Supplementary add up to 180. So that's the relationships. B and C are congruent, they're the same. Same measure, they're equal. A and B add up to 180, A and C add up to 180. Okay. So, with that said, based on your observations, write a conjecture. So, let's explain what a conjecture is. A conjecture is an educated guess based on evidence. A conjecture is a hypothesis. A conjecture is we just had evidence. What was our evidence? Well, when we were solving this, we Excuse me. When we were solving this, we noticed that these two were the same, and those two were the same. And we want to conjecture about the vertical angles. So we want to make an educated guess about B and C. So I think vertical angles, that's your statement, have the same value, are equal. Let's use a good math word, congruent. They're congruent. That's my guess. So that's what a conjecture is. It's a guess based on evidence. This is the least amount of words I can use, and I'm all using all math words. I can say angles, when two lines make an X, the angles that are straight across from each other are equal. That would be a better way. That means you don't have to know any words. So, because this, if you don't know what a vertical angle is, this is a very unhelpful conjecture. But when two lines form an X, the angles that are straight across from each other are the same, is what that means. Okay, let's see what we got. Jacob wrote the conjecture, vertical angles are congruent. Good for Jacob, so smart. He's noticed that A and B add up to 180, and A and C add up to 180. Why is this true? Well, A and B add up to 180 because they're a linear pair. And A and C add up to 180 because they're a linear pair. And that's what linear pair means, is that they're supplementary, and supplementary angles add up to 180. So something like that is what you're looking for, because they make lines, because they form a line, which is what linear pair means, is that they form a line, because angle A and B form a line, because A and C form a line, because they're linear pairs. But the reason it's true is because of linear pairs. Okay, questions? All right. So